Go ahead.
Yes, I am Ravi Sharma. Today is April 27, 2022, and we are in the environmental disasters track of the Pandemics and Disasters Summit 2022. It gives me great pleasure to welcome you all, and especially a panel of 4 speakers whom my co-champion for the track, Gary Bergcross, will introduce. Thank you for joining us and welcome everyone.
Thank you for the introduction, Ravi. I'm Gary Bergcross, and no contemporary discussion of environmental disasters and issues would be complete without including the challenge of our time, which is climate change, and all the related challenges that flow from it and are enhanced by it. So we understand climate change as a multi-layered and time-crossed complex phenomena, which makes for a variety of data variables, models, and semantic challenges. There are many interlocking scientific models that we know that are involved. And we also know that communicating some of this understanding is difficult between scientific disciplines as well as to the public. So this afternoon, we are very happy to have a suite of 4 talented people who can help us understand some of the solution approaches. In particular, we're going to be focusing on 2. One is the IADOPT, or interoperable description of observable property terminologies from the RDA working group, and the other is the We Adapt, an activity hub. So now our panel of 4 people includes, in order of expected speakers, Barbara Magagna, who is a landscape ecologist working in Vienna, where she has the role of semantic analyst and database designer. Besides IADOPT, she was involved in the development process and coordination of the Toronto Ontology, which stands for Socio-Ecological Research and Observation Ontology, that enables somewhat seamless presentation of observable data from different origins, as well as the NBES, or Environmental Thesaurus, controlled vocabulary for long-term ecosystem research. We also have a Sirko Schindler, who received his education as a computer scientist from the Friedrich Schiller University in Jena, Germany, and is currently awaiting his PhD. He worked in the fields of data integration and visualization. He's also part of the IADOPT work as a senior researcher with the Institute of Data Science of the German Aerospace, where he's responsible for efforts on metadata, provenance, and knowledge graph. By the way, there's more detail on each of our speakers on the website. So I'm just doing some highlights of these very talented people. From We Adapt, we have Julia Barrott, who is research fellow and knowledge manager for the global We Adapt knowledge sharing platform for climate change adaptation related issues. She also assists the head of knowledge management at Stockholm Environmental Institute, SEI. Julia's work blends capacity building, research, and tool development to advance climate services, knowledge management, and knowledge brokering for climate action. And finally, we have Sukaina, from who has a PhD for applied computing, social sciences, and a BA in social anthropology, and a wonderful example of a modern interdisciplinary researcher, background in both social and computer sciences, which are needed for innovative climate adaptation research. She coordinates the strategic and technical development of the We Adapt global platform and network for climate change adaptation. Sukaina co-led the SEI Climate Service Initiative and several work streams in large European and international projects. I want to thank all of these people for generously agreeing to help educate us today on the topic. With that, let me turn it over to Sukaina.
Thank you, Gary. It's great to see everyone here. Hello. To start our session off, we thought we'd try and find out a little bit about who's in our Zoom room. And so we're going to run a bit of a mentee session very quickly. So if I could ask you to go to the link, the mentee link that you can see in the chat here, in the Zoom chat, hopefully, or in the chat room, if you're in there. You can go to the link, or you can go to mentee.com and use the code 87648954. And tell us a little bit about your background and your interest in this session, what you're hoping to get out of it.
So we can write right on the document, Google document.
Yes, exactly. And I'm going to share my screen and we should see some of these results popping up. If you go to that URL, mentee.com, then you should be able to see a place to input some of those questions, some of your answers to these questions. If anyone's having trouble, just let me know. There we go. So hopefully you can see my screen. So we have people with a background in ecology and knowledge engineering, interests in fair data management, space sensor platforms, I don't know what they are, image data, constellations, interesting. Great.
Sorry, may I do it later or just now?
Now.
If
No,
you could
okay.
do it now, it would be great. Yeah, we have some time, so
Good.
don't worry. It's quite a technical mix of people here, it looks like. That should be interesting for some of the work that you're going to hear about, probably. People interested in knowledge graphs or have backgrounds in knowledge graphs, and is that knowledge elicitation, knowledge engineering? Okay. Semantic data, integration, programming. Brilliant. Already some connections being made through this word cloud. That's good. I would like to know what space sensor platforms are as well.
Oh,
Um,
if I may respond, I mean, some of us are responding. We are only 10 or 12 here. I mean, 15 people in total. So it has to be one of us, and I wrote that. How
Okay,
anonymous you want to keep it?
We
I
should then
think
also
someone's.
continue.
Sorry, go ahead, Barbara.
I think we should continue then to the next question, because discussion will be then at the end, I think.
Sure, yeah. I think, Ravi, somebody's asked in the chat if you would contact them privately. They're interested in these space
Of
sensor
course,
platforms.
of course, yeah.
Great, brilliant. That's really helpful. So then one more question before we get into the presentations. Could you tell us something about what your current ontology challenges are? What are the challenges you're currently facing? Hopefully your Mentee screen should switch to the next screen for you to input some new answers. Interesting. How much is enough? Like a never-ending task, I guess. Yeah. Harmonization is a common one. Alignment and harmonization, are they the same thing? Integrating data from multiple sources, yeah. So it's kind of like a similar thing coming up here, harmonizing conceptual definitions and ontologies. Relating data models to ontologies in a useful way. Multiple definitions of concepts. Mapping natural language to predicates. Okay, great. So a lot of common challenges, it seems, here as well. So, okay, without further ado, then I will thank you very much for that, for participating in that. I will hand over to Barbara to kick us off with the first presentation, and we'll come back to this Mentee discussion or sort of opportunity to share some information towards the end of the session. So if you can keep your browser window open, that would be helpful. Okay, Barbara, I'll hand over to you.
Yes, I think.
And I will stop sharing. Yeah.
Okay. So I hope you can see my screen.
Yes.
Thank you very much for having this opportunity here to speak with you on a topic which is really a topic that was part of my research over the last 20 years. So I'm a landscape ecologist, and I started observing phenomena in nature and tried to gather some metadata about it. And therefore the title of our presentation is How to Make Climate Research Interoperable with IADOPT from Field Observation to Data Publication. And I will introduce to you an approach, a solution developed by the IADOPT working group, the interoperable descriptions of observable property terminologies. This is the RDA working group that I initialized 4 years ago, in the beginning of 2018, as a very informal group under the Vocabulary Service Interest Group. I started this initiative because I had to provide terms, terminologies for my research infrastructures I'm involved in. That's the ELTA Long-Term Ecosystem Research Network. And these are all field scientists and also researchers using this data, these observations from different phenomena. And we are all challenged by the necessity to document what we are doing. But the problem is that we all use different terms for doing this, and we need a common harmonized approach. And I thought I could do it for my research infrastructure because I'm coordinating ENVTES, environmental disasters, but this will not do it. I need really to see how others are doing this and understand how this can be done more systematically. And I was involved in ENVI-FAIR, the ENVI Cluster Environmental Research Infrastructures Cluster, I try to find synergies, also other developers that could advise me how to best do this. And I found out that nobody knew it. So everybody had the same problem. And I thought, well, that might be a good issue to be discussed in a broader group, and therefore we started this working group IADOPT officially in 2019, and we finished it in autumn last year. So, well, it was in November. And finally, last week or 2 days ago, we got the endorsement from the Council of the Research Data Alliance. And next week the recommendations will be published. So I think that's a success story. Now we will see how many will are willing really to adopt this system. So I started this initiative together with Gwen Moncafé. She is a coordinator of the NERC Vocabulary Services. Anu Seria de Barrayo, she is working at TERN in Australia. And Maria Stoica, she is at the University of Colorado, and she co-developed the scientific variable ontology. Yes, and Sirko Schindler and Alison Pamment are also part of the core group, core developer group, and Sirko will speak after me. Alison Pamment is from the CN Standard Names, CF Standard Names initiative. So what is our goal? We want to address the interoperability of the FAIR data principles. So we want to enable interoperability between existing terminologies, and we want also to promote the use of these terminologies. And our challenge that we want to address is that we would like to find a solution how existing descriptions of what we observe are mappable to each other, so that we really understand if a variable description in one vocabulary is really the same, or is the exact match with another variable, for example, published in Envo. We never could really do this. Very simple parameters might, wind speed or speed of wind will be okay to understand, but there are much more complex descriptions that we need for complex phenomena. So what do we understand under variable? That's a synonym for observable property or parameter or quantity kind, but we have also quality kinds. So not only numbers that we have to represent, but also qualitative terms. So the concept, the variable in IADOPT represents what has been observed independently of where, how, and when data acquisition took place. That's important to know. And we are highly inspired by existing approaches like the complex property model from Bradford and Fodden, and scientific variable ontology from Stoica and Beckham. So we think that a variable can be represented by a combination of descriptive components, giving meaning to the value derived from a data acquisition event, and be it an observation, a measurement, a simulation, or also a calculation. And important also to know, so we are not describing an existing tree or so, or an existing situation or climate situation, but we are describing variable types of these properties. So let's make this a bit more concrete. Imagine we are observing a mean dissolved in nitrate molar concentration per unit volume in precipitation water at a specific location, Emerald Sea Coast, in micromole per liter by sampling. This is an observation. So what is the variable part of this observation? It's the yellow part in the middle. It's mean dissolved nitrate molar concentration per unit volume in precipitation water in micromole per liter. And we don't include the feature of interest, if people know this term from SOSA, or observation and measurement. So it's not Emerald Sea Coast, it's not our interest to describe here, and it's also not method. We are not including method here. We concentrate on the yellow part. And we think that this part, this sentence can be decomposed in its descriptive elements. But the question is how? We can identify these components here: mean dissolved nitrate molar concentration per unit volume, precipitation water, and micromole per liter. But we found out that probably not everything should be included in this variable description. So mean is a statistical measure, needs this supports that you have already different observations and you collect them together, and then you make a mean. So this happens afterwards. And the micromole per liter is a unit, and is very important. If you have quantitative values, you should include this in descriptions, in metadata, but not in the variable, because a variable can be expressed in different units, and therefore we exclude it here in this description and focus on these four in this case. And then what we also then suggest is that once you have detected the elementary components, you have also to find a concept in existing semantic artifacts, thesauri, ontologies, vocabularies. And if this doesn't exist, you have to create one. That's our approach, but how we do it, we have developed a syntax, and Sirko will take now over and bring the details on this.
Wonderful.
Sirko?
Yeah. So next slide, please. So Barbara already showed that we try to decompose the existing variable descriptions into more atomic components that actually represent their content as well. But obviously you need to represent their roles in this variable also. So what we came up with after quite some discussion is this rather small model to capture all these relationships among the concepts. So on the right hand side, you have the property. This is the stuff that's actually measured, the physical property or quality. Then you have certain entities that are involved in different roles. I'll talk about them right after. And then there's constraint, which somehow give you additional information. So you're measuring something at a specific height or depth or under certain conditions, and those would be contained in the constraints. As for the entities, we are currently distinguishing 3 different roles for entities involved in the observation. First of all, there's the object of interest. This is the main focus of the observation, so the thing whose property you're actually measuring. And then you have the matrix, which is something that the object of interest might be embedded in. So our prime example before was measuring a concentration within the flat. No, still best slide. Measuring a certain concentration of a chemical compound within oysters. So in this case, we are measuring the object of interest would be the chemical compound, and the matrix here would be the oyster as a medium of that object of interest. And lastly, we have the context object, which captures all the other things surrounding this measurement that is required to accurately describe this measurement. Now, next slide, please. So coming back to the example that Barbara showed before, she already had this decomposition, so we have already seen them, and now we have to assign the distinct roles here. So as you can see here, the main object of interest that we are measuring here is the nitrate. So this is now an entity in the role of object of interest. This object of interest is constrained in this case, meaning here it's dissolved. And where is it dissolved? Yeah, it's dissolved in the precipitation water of the measurement. And lastly, we have to specify the actual property. In this case here, it's the molar concentration. So this is this last part here to the variable description. In this particular case, we are, or in this example here, we are referring to the Oscar Thea vocabulary. So they already defined all of those concepts and are one of the early adopters of iAdopt. So as you can see here on the bottom, on their Cosmos instance, they are not just publishing the observable property descriptions, but also already this decomposition into the iAdopt concepts that you can see here on the lower left-hand side. And if somebody actually wants to check on the right-hand side, you see the URL where you can reach this very page, which is also part of these slides that you can find on the event homepage as well. Next slide. So what do we get actually by this? So first of all, we are getting some more precise description of those variables. So it's not just this big monolithic something, but we are really getting some more detailed information about it. And by decomposing those descriptions into more atomic components, we reach something, or we reach a state where we can more easily map across different terminologies, probably or likely describing the same thing. So the issue that Barbara mentioned at the beginning, different vocabularies describing the same thing, but by different means. And here, by decomposing the thing, this variable, the integration or alignment of those terminologies gets much easier. Next slide. So what we see, or iAdopt, we see as this kind of semantic broker between those terminologies. So we are enabling the mapping across different terminologies by providing the means to those alignments to actually be automated or at least be supported, and you don't have to do it manually all the time. What we also do, it doesn't really require any change of the essential or initial structure that is within the terminology provider. So this is just an augmentation to already existing stuff. And as Barbara mentioned, our main focus is interoperability, but here by the means of decomposing and providing more detailed information, this also improves findability and reusability. So the F and R of FAIR as well, not just the I. Next slide. For creating those variable design or those variable descriptions. As you've seen here, this was a rather simple example where I guess most of the people, after reading our documents, would be able to do that. But in some occasions, this decomposition is rather difficult and even costs us quite a lot of discussions until we arrived at a point where we agreed that this is the actual decomposition of that variable. So to foster or support this process, we started now having something called variable design patterns. So those are kind of templates that give you an idea how to decompose your variable description. They are meant, first of all, as templates for creating new variables, but also as a sample or a starting point to get an idea of how to do that in general. So if your variable doesn't fit any of the existing patterns, you at least get an idea of the intention that we had with this decomposition, and it might provide you the starting point for doing something on your own. In general, these templates or design patterns are domain independent and rather abstract. So this is not something that you can immediately use to describe a variable, but it's meant as a tool to create your own variable descriptions. And lastly, as the constraints are really specific to individual variables, they are usually not included in those design patterns. So design patterns are one step above that in terms of abstraction. Yeah. So again, starting from the example we had before, if we are trying now to do here a little bit more abstraction or try to generalize it, next slide, we arrive at something like this. So from this molar concentration per unit volume, we can abstract kind of to a more general term of concentration. So there's different types of concentration, but anyhow, the core meaning of concentrations is roughly the same each time. And then from nitrate, accordingly, we can abstract to chemical entities. And from precipitation, we can generalize to anything regarding the water cycle. So there's different instances of that. Next slide. Oh, right. So, and then, one before. So if you combine that, those pieces, we arrive at a design pattern. So this design pattern says, yeah, if you have a property called concentration or something that is a concentration, you could have something as a chemical entity that is dissolved into some water medium, for example. Next slide. And if we have that, then we can immediately generate much more variables by instantiating those with the other type or the other instances we have of individual types here. So for concentration, we can immediately derive something like mass concentration, molar concentration, etc. The chemical entities, obviously, we can list all of them. And then we have the different ways of, or the different types of water in here, stream flow, surface runoff, or the precipitation we had beforehand. So this really gives you kind of a framework to immediately create variables for hopefully most, or if not even all of the stuff that you need to describe in your part. Next slide. So as part of the IADOP working group, we generated now quite a bunch of outputs. As Barbara mentioned, those are now since like 2 days or so a RDA recommendation. So in particular, this is the framework that we quickly introduced here. There is a whole, there's a different document that describes rational and the specific entities, etc. in more detail. Then we created a catalog, which is currently focused mostly on environmental sciences, but provides you with the concepts that you need to describe each and every component in such a decomposition. And then there's some supplementary material, like alignments with other existing ontologies, like SOSA, etc. Our current variable design patterns, but note this is still under construction, so here some more will be added. And we already have some implementations of the IADOP model. As you have seen before, this was Oscar, Thea, and the NERC vocabulary started it, ENVTest started it. So there's quite some uptake already of this model to describe the variables. And lastly, we also have this step-by-step guide, which should allow knowledge engineers or give knowledge engineers a kind of workflow to minting new variables or variable descriptions to be more precise, and give them some help in where to look at, what to think about, etc. Next slide. So what we actually do, or where we are currently at the beginning, we had this, we had a lot of terminologies describing maybe the same thing, but we really had the problem of mapping in between. So the interoperability between those was kind of hindered. now we develop this I-adopt interoperability framework as a means of connecting those. And our plans for the future is now to really put that into code. So develop converters between the terminologies, connect between them, and also have dynamic mapping tools. First of all, to map between the terminologies themselves, but also to map between your description of a variable, not so much in a formal way, but in an informal way, towards a formal description of such a variable. And this then hopefully enables users to do a whole lot more with their data afterwards, like supporting this annotation process, helping people discovering the data set that they actually need, and overcoming this lock-in within certain terminologies, as we mentioned multiple times, with alignment or harmonization of terminologies, and finally data integration as the, let's say, more ambitious goal than to automate here as well. Next one. And then here, finally, again, the people involved in the I-adopt working group that Barbara already mentioned at the beginning. So this is the core group that has been working most on this model, but we had input from several others throughout several workshops. And on the lower end here, you see 2 URLs, and you most likely find them as well in the PDF on the homepage. So first of all is the GitHub repository, where we store all the ontologies and all the material that I mentioned before. And then we have the RDA working group page, where you can find additional information and also notes, slides, etc. from our past workshops. And with that, I'm handing over to Julia and Sukaina for their part of the talk.
Great, thank you, Sirko. Thank you, Barbara. And thank you, Gary, for the invitation to speak, and thank you everyone for joining. It's good to see you. Lots of faces working on this topic. So Sukaina and I are going to talk about moving from data to interoperable information and knowledge in climate research, at least from kind of where we're coming in the climate change adaptation field. So this work builds on our experience with the WeAdapt global knowledge sharing platform for climate change adaptation and related issues. As Gary mentioned in the intro, Sukaina is WeAdapt's coordinator, and I'm one of the knowledge managers. Slide, please. So we're not taxonomy and ontology experts per se. We're very much coming into this area of work from the application side of things, but we're really keen to learn. So please do comment away in the chat, and we'll try and connect on some of these issues. So WeAdapt's a user-driven platform with over 2,500 articles and case studies and associated user and organization profiles, and these cut across numerous topics, approaches, and contexts. It's used by quite a diverse array of people. So we get about over 150,000 unique users a year, and these include government offices, sector professionals, researchers, practitioners, students, and also the general public. So of course, one of our key aims of the platform is to try and make it as easy as possible for users to find the knowledge they're looking for, and perhaps even find things that they weren't looking for. So one of the ways that we're doing this is using keyword tags. Slide, please. This is essentially what brought us to work on taxonomy and ontology development. So we apply these keyword tags to each of the content items. So here you can just see just below the center of the screen. Sorry, it's a little bit small, but we add them to articles, case studies, and organizational profiles. And if we go to the next slide, you can see we actually make these clickable. So when you click on one of those tags, they pull together all the content that's tagged with that specific keyword, which you can see on the left here. They also power our faceted search function, which you can see on the left. So we use the keywords to help users filter and drill down into the content to bring it down to what they're looking for. So if we jump to the next slide. So at the moment, these keyword tags are driven by what's quite a flat, unstructured vocabulary. Is very much user driven, so users have contributed tags over the years. We've now moved to quite a systematic application of that. So myself and the other knowledge managers are very careful in how we apply tags. They use quite a smaller vocabulary, but it does mean that we have a very rich source of concepts. But we're not the only kind of platform that uses these tags, and we're very interested in kind of using the taxonomy and ontologies that they can link to in different ways to really improve the functionality of these online platforms and enhance the discoverability and accessibility of the content they host. So we want to be able to make it easier and faster for users to search and discover content, to filter it, to cluster it in different ways. We're interested in developing tools that can dynamically pull different content without this having to be, manually hard-made links between a tool interface and the content. So we want to move towards platforms that can suggest and be responsive to users as they're inputting information in their journey around the platform or the website, if you like. One of the big things we're really interested in is interoperability. So this is especially important in climate change and climate change knowledge sharing, because knowledge relevant for climate action is scattered across numerous discrete websites, not all of which have good search engine optimization. And this fragmentation of online knowledge makes it really difficult and time consuming for users and non-experts in particular, who aren't aware of what the key platforms are they can go to for this knowledge to find what they need. And there's a lot of this now, the one thing we don't have with climate change is time. So if we go to the next slide. So what we're trying to do is develop taxonomies for climate change adaptation and disaster risk reduction. These are two key fields in acting to reduce the impacts of climate change on society and the wider environment, and to make these widely available for platforms to use, different online platforms, so that we can all use these tags or all use basically that same taxonomy ontology infrastructure to connect the content and knowledge across our platforms. So Sukaina will in a minute show how we've started to do this in practice with a partly harmonized vocabulary that uses each of these platforms' existing tags. But what we want to do over time is actually build a much more structured hierarchical taxonomy and thereafter ontologies to add more information and more structure to this content. We're currently doing that at the moment, so we're using existing glossaries, terminologies, platform vocabularies, and a clean version of the WeAdapt vocabulary, and trying to introduce structure to that using existing classifications and input from topic experts. But this is all quite preliminary, and I think what iAdopt is doing is fantastic, and we've got a lot to learn about how to do this in a much more systematic and precise way. So I'm definitely going to be diving a lot more into that. One of the big challenges we face with this, and you'll see so can discuss this in a bit as well, is that a lot of the terminologies we're dealing are quite disparate. So I mentioned climate change adaptation and disaster risk reduction. These are examples of two fields that have a lot of overlap, two separate fields of research and practice, lots of overlap, but they use the same terms in different ways, and they have different interpretations. And within each of those fields, some of these terms evolve through time, their use and their inference evolves through time. So it's quite complicated kind of semantically. So we put a lot of emphasis on really looking at adding lots of alternative labels, multiple definitions, and scope and use notes. And you'll see that in the tool that we've developed that Sukaina will showcase in a minute. So if we jump to the next slide. So this is kind of a quick overview, and this is the taxonomy development we're working on at the moment. It's just a small component of kind of what we have, a larger vision we have for how ontology can support climate action. So this is encapsulated in this publication here. It's got quite a decent snappy executive summary, so don't feel the need to read the whole thing if you are interested. But we put this together in 2020. It's a roadmap for the collaborative development of taxonomies and ontologies that could be widely used by online knowledge platforms and repositories to connect our kind of global collective knowledge, with the aim of making this more findable and accessible and supporting knowledge and transfer and uptake, one across different research and practice communities, such as adaptation, disaster risk reduction, but also across kind of geographies and contexts, because there's things being learned about what's working, particularly in terms of climate change adaptation all the time. It's kind of stuck in different areas. So we want to connect this and kind of make it more accessible. So it's a very ambitious vision. We're learning a lot, and I'm sure we'll learn a lot more today, but it is something that's getting a lot of traction amongst climate knowledge platforms. So if you are working on relevant taxonomies and or ontologies, would like to get involved, would really like to hear from you. So I think our emails are on the last slide. And with that, I'll hand over to Sukaina, who will show you one way in which this work, or we're currently using this work to kind of transform accessibility and discoverability of knowledge. So thank you, Sukaina.
Thanks so much, Julia. So, as mentioned, one of the challenges we're facing is this overload of information and a lot of this siloing and fragmentation of information. And as Julia mentioned, we've tried to address this with an application of a tool that is attempting to implement a taxonomy, which would hopefully turn into an ontology, to visualize the content of the climate change adaptation content and the disaster risk reduction content from many different online platforms. So we currently have about 5 or 6 platforms sharing their data on this tool called the Connectivity Hub, which is to enhance the search and discoverability of climate change adaptation and disaster risk reduction information, to enhance collaboration and coordination, and to build capacity and awareness of work that's being done, and also how language is used. If you want to visit the hub, the URL is here, and we'll share that later. So basically what the hub does is take some of these key terms, the tags that platforms are using. So this is the orange node here that you see in the network graph. And because content on each platform is tagged, these blue nodes are different types of content from platforms. This will become clear in a second. And the green nodes that you see here are the organizations contributing this content. So we realized quite early on in our We Adapt knowledge management work that the way we've structured content on We Adapt allows us to visualize the information in this way, and that visualizing this way could be more helpful for users. So all of these things are connected in this way, and then to provide more value from these keywords, we are translating them into a glossary, providing definitions and more context about how these terms are used by different communities in different ways. So one of the reasons we're doing this is because we can provide more visibility for source platforms. So we have at the moment several of these platforms working at the European level, one's working on DRR internationally, We Adapt itself. And what the application does is, if you're searching on content around flooding, for example, you'll find many different sources of data sharing content on using the keyword flooding. And so the harmonization of anything to do with flooding is one of our challenges. Like, we have a lot of content that describes flooding, not using the keyword flooding, for example. But if you were to click on one of these blue nodes, the articles, you would see a summary of the content, and then you could go to the source platform here, in this case, Prevention Web, and you would be taken through to the content. Similarly, for Climate Adapt here, you can see the keywords, that the other keywords associated with it. You can click on those keywords and terms, and then again visualize the landscape of the content associated with those key terms. Otherwise, you can go to the source platform. So as Julia said, the reason why this is possible is that on We Adapt, we use all these keywords. Climate Adapt, Prevention Web, and others are all using keywords in certain ways, but they're actually not using a taxonomy in any real sense of the word. And some platforms are actually just using key terms to describe content. So there is no structure and very little sort of classification of these terms being applied. But there is a really rich knowledge base still to draw from, because a lot of this is expert driven. So a lot of these terms are being applied by experts, but they're not being utilized in the form of a taxonomy or an ontology. So this is really a missed opportunity that we're trying to sort of, take advantage of in a way. So the value of this is, for example, as I said before, if you click on a keyword like nature-based solutions, that is a term that has evolved over time. As Julia said, it's evolved as the fields evolved. Some people use the term ecosystem-based adaptation. They can mean slightly different things. The system can suggest to you alternative labels that may be used if you're looking for this search term. And this is really valuable for you people who are new to climate change adaptation, or students or people who are just trying to learn about the issue and they don't know what they should be searching for. So the system can suggest new searches. You also have these suggestions of, have you considered other related terms? So terms that would be related to nature-based solutions in the taxonomy. And if you were to click on those terms, you would see the new visualization of that knowledge in the landscape. And then, as mentioned earlier, we provide scope notes for how these different terms are used. So the adaptation and DRR community may use these terms slightly differently. And we want to make sure that this is all captured and the user can click on these definitions and find the sources for these definitions as well. So just in very quick summary, the reason why we hope this is of value to the climate change community is because we're not trying to create another platform. This is really a tool to harness the power of taxonomies and ontologies for making content more easily discoverable and also potentially revealing unexpected connections between the data. It's very important for us to link different types and scales of knowledge and try and reduce these silos and the fragmentation of knowledge that we described earlier, and also to build a shared understanding and awareness of different terminology used. So not to impose a particular terminology, or even, to what extent we would harmonize the terminology is up for discussion, but more build awareness of the different terminology and how this is used is very important. So this would support a lot of our learning and capacity development goals in We Adapt and SCI generally. And we're also in this way hoping to create not just visibility for these platforms, but also cross-fertilizing this knowledge and increasing collaboration and communication between these different communities of practice and research and practice. So lastly, just to say, if you want to explore the hub, there is some guidance information on the website. There's a 3-minute video that tells you all you need to know about how to use the Connectivity Hub. And it's also available in Google's 124 languages, I believe, right now. Here are some links to our papers and the taxonomy we're developing and working papers, the roadmap, etc., that Julia mentioned, and these will be available in some slides later. So with that, I think I will hand back to Gary. Thank you.
Thank you. That was very good. I have a question or two that I might ask to start, if that's okay. For Barbara?
Yes.
And Sirko, which is, could you tell us a little bit more about how your approach works with some of the climate change topics that Sukaina and Julie, for example, discuss? I'm looking for the relationship here. I thought there were some examples of climate change phenomena that you already looked into.
Sirko, would you like to start? Or?
Yeah, so I think the approaches are complementary right now. So the Connectivity Hub is pretty much a little bit more top-down. So you have the, it's bottom-ups that way around. They're looking for the atomic components within the documents, data sets, etc., and then building up a connection hub between that. Whereas we are more from the other way around. So we have some really complex descriptions already, and we're trying to decompose that. So the connection between both is pretty much in the middle. So we could, or the IADOP approach could be used to connect the individual terms to actually also capture their relationships, not have them as individual terms, as tags, but really, capturing the relationships and thus providing some more semantics around that.
Well, yes, it sounds like some good future work between the two groups would be wonderful.
Yeah, I also am looking for that. Would be great.
I put into the other chat, that there is relevant work within ESIP, Earth Science Information Partners, that we might put together with this effort, might be of mutual value. And I was wondering if either of the two groups has looked at Envo, the environmental ontology, any extent. I put in the chat an example of the concept of flooding, which has many related terms of types of floods and so forth, and it's been axiomatized. And so if you look in there, the definitions are sort of consistent with the axiomatizations in the ontology, and therefore they are potentially very useful. And I wasn't sure if either of the groups had looked at Envo as a possible source.
Yeah, for sure. Envo is a source. You can potentially use any ontology or thesaurus for these decomposed terms. But I think Envo is going beyond. So we are not explaining a phenomena. We are just describing a data set or the outcome of an observation values with what they represent. So we are not really explaining what the phenomena is, but what has been observed. Yeah. So I think Envo is going beyond, really explains more, but yeah, our approach is more semantic broker than a knowledge, yes. And then ontology, which explains the world. Yeah.
The other thing for we adapt is the use of something like triple SOM, which is Simple Standard for Sharing Ontology Mappings, which sort of allows you to sort of have a uniform way of documenting the relationships between terms in different ontologies, or in your case, maybe just in terms of different vocabularies. And so that might be something that you might look into for use. It's called SSOM. Maybe you're familiar with it.
Great, thanks, Gary. No, I don't think we are familiar with that.
And of course, it makes use of, among other things, you can define your relationships between the vocabularies, and people are familiar with SCO. So, for example, near match, close match, and exact match, and so forth are some of the relatable terms that people use to define the mappings between the various terminologies or ontologies.
Okay, great.
Before we get to your three important questions, let me just turn to the chat and see if anybody is going to raise their hand within that. That's the way we normally do it, to see if they want to ask a question. Usually Ravi has a question, so maybe I'll just ask if that's the case.
Yes, I always have questions. My request is twofold. One is relating ontologies to metadata, and some of it you have addressed in the chat. The speakers have responded already. Thanks for that response. But also is the question of how do you handle divergence and dynamic patterns. So by divergence, I mean when something goes out of what you define as being semantic, how do you take care of that part? When do you say, no, now it is out of validity region and our bounds are not being met?
So are you asking I adopt, or?
It could be I adopt, yes. Or
I can answer about that. So what we propose is an approach, and we will provide better and better guidelines and hopefully services that are able to really help, in this decomposition. But we cannot avoid that people are doing it differently. So that's always with vocabularies. These are is not a centralized solution. So you don't have one vocabulary, you have many. So it's a distributed approach, and it will always be like that because you have to be from the domain, and there is no possibility to centralize this thing. But what we also want to do is to initialize discussions about how this can be used, and therefore we have a GitHub repository where people can discuss with us this modeling. We cannot avoid this, but we think that by trying to describe this in more and trying to decompose this and find the roles, you are much more precise than before. So it is an advance anyhow.
Thank you. Thank you. One more question on the visualization. Through graphs that Sukaina presented, was not only just entities and knowledge graph-like representations about them, but also the extent to which different communities use those concepts by varying the extent of the blue within a circle, for example. Can you explain how successful this presentation has been to the users?
To some extent, this tool hasn't been that widely sort of, I would say, shared yet, and therefore not widely used yet, because we have still a lot of work to do in the taxonomy development and in sort of making sure that the terms between the different platforms are harmonized. But I mean, initial feedback we've been getting has been very, very positive. I think there is still a balance to be met between, I mean, you could argue that the way the information is presented in the hub is also quite overwhelming in one sense, which is one thing we're trying to avoid. But we're doing a lot of sort of thinking around how to, different ways to filter that information further for different platforms or for different sectors, maybe for different countries and different climate risks. And so I think the sort of evaluation of the use of the tool is still to be done. But so far, I would say feedback has been pretty positive, because there's no real other way to visualize this information from different platforms in one place in a sort of, you know, sort of equitable way, in a way that everything is equally presented. In terms of, I don't know whether you were mentioning about the sort of distance between the nodes and whether they represent anything in terms of the sort of connection or the number of terms that are connected and the distance between them, but that isn't so significant in the way that the data is presented in this particular example.
So how do you incorporate other dimensions? You mentioned organizations involved. So are there any attempts at 3 or more dimensioned projections in these multi-dimensional data?
It very much depends on the platforms that we're working with. So most platforms do seem to be sharing data like about a project. It has usually organization information, and there are usually keywords. So those 3 bits of information are kind of common across the platforms. Some platforms like WeAdapt also include sort of individual user information, but not all platforms do that. And so in terms of harmonizing the data, it's quite a large task to sort of make sure we have enough commonality between all the different data sources to present something. So at the moment, these sort of 3 entities are the common things across all the platforms.
So my last question for Sirko and Julia, maybe, that is, how do you handle divergence when you know that something is getting out of bounds, so we need to just neglect it or not include in our data set, or don't show any keywords about it, as well as dynamic design patterns, because life is all about changes. So when your design pattern doesn't match reality, what do you have to exclude it and indicate it that it is getting out of divergence?
So I think for the design patterns, the patterns themselves will not really go out of use. So they are meant to be generic enough that they hopefully can be used all the time. As for the actual variable descriptions later on, so far we haven't really considered semantic drift or anything like that. So I would assume that the same stuff that you apply to quote unquote normal ontologies also when the semantic meaning has shifted sufficiently enough, and then just assign the proper provenance trail to that new concept, pretty much stating, yeah, previously it was called like that, but now meaning has shifted. So I would assume that something similar applies here to variables as well.
Thank you.
Yeah, maybe I can jump in there. It is one of the challenges, especially in the kind of more social science aspects of climate change. So there's a lot of introduction of concepts or new terms, and some don't make it, others do, and they do change in use. So this is why you saw in the connectivity hub, you get pop-ups on just different terms. There's a lot of information on the use notes of those terms, and we try and keep those updated with how the use of that terms change through time. And that's very much to kind of support the users to understand the provenance of those concepts and how that's being used. And as Sirko said, to redirecting it to the most relevant concepts of the time when you do have concepts that have gone out of date, as it were. So that's quite a challenge. We're kind of looking at governance systems that we can use, in collaboration with others to kind of keep those things updated in the taxonomy.
So I would make a quick comment before we go to Mike Bennett, who has a question. My experience with design patterns is that often when you're getting something that doesn't quite fit, you're questioning whether it's a subtype that's specialized in some way, or whether there's another relationship, like something playing a role or a different mechanism involved. So essentially the pattern still gives you a way of starting. You may then specialize the pattern or broaden the pattern or connect it to another pattern so that there's an interaction. So there's this obviously drives things. When you try to deal with complexity, you start with something that is handles a lot, and then you gradually over time extend it and revise it and test it again. So with that, let me turn it over to Mike.
Sorry, can you just react on what you said?
Sure.
My PhD, so I'm writing a PhD, is only about these design patterns and about ontology driven design patterns. So I will really try to find out if they hold what they promise with many different use cases. So we are going to further develop this.
So we'll stay tuned.
Thank you. Yes, very good. What about Mike now?
Hi, everyone. Yeah, so this is a question for Sukaina. I like what I was seeing in the interface to and I should mention that I'm currently working for an organization that does a similar kind of thing for legal and financial reports and things. So taking information from different sources and having subject matter experts kind of put things into alerts and reports and things. So a very practical question. The tooling that you're using, was that built out of existing like open source components, or is it your own tooling? And the second related question is the way you build it kind of very much locked into the climate change sort of knowledge set, or is it something that could be used in other domains as well?
Thanks, Mike. Interesting that you're doing similar things in a different sector. That's great to hear. The tool is something we've developed with our, we have developers we work with on We Adapt, and we develop a bunch of tools as well as the platform. And so it's something we developed over a few years with them using open source libraries, open source network graph libraries. So it's not stuff that's sort of customized by ourselves or anything like that. So in that sense, I mean, obviously we're developing this very much for a climate change, the climate change community, but yeah, in theory, it could be applied to other sectors for sure.
Thanks.
Well, I have one comment before maybe we turn to your three questions that you want to use, which is that my observation is that We Adapt is working at sort of a large knowledge management level. And I adopt is working at a much more refined level, and there is that interesting semantic analysis work to be done in between that might bring these together over time. It's a long process, obviously. That's where a lot of the action is, how to leverage some of these refined, templated type of things with the large knowledge management, huge things of topics and writings and so forth. There are some tools for, for natural language processing that sometimes gets used to sort of, let's see what the concepts are in this discussion. And that's a way of picking out what maybe some of the core concept terms that might be then relatable back to some of these patterns.
Yeah, absolutely. And I think because We Adapt is working with qualitative data, as Julia said, there are so many challenges with that, but part of this sort of decomposition of data that iAdopt is using is something we've very much come across and recognize we need to sort of improve the different sort of combinations and permutations of how data can be discovered. And so, but how we actually do that, yeah, is something we really want to learn more about from people who have experience.
Okay.
If there are no more immediate questions from the presentation,
I have one Gary,
okay.
I have one last one, which is how do you keep track of the users? You have done so much wonderful work. How the user community is adopting your tools? Is there a measure, metric, or periodic monitoring?
So I can answer a little bit on this. So what we, I am involved in Envo Fair, and there we have quite some research infrastructures, and we did quite many workshops, interactions with those, and they're coming back to us, and we will most probably continue to give workshops, so to see what are the requests and necessities, so that so I cannot really keep track on what they are doing, but we try to be there to help, yeah, and to further to foster the discussion around this, to make it useful.
With regard to We Adapt, sorry, go ahead, Barbara.
No, I just want to, does this answer your question somehow?
Yes. Yes, it did somewhat, but then you are also doing these surveys. So with similar response from user community, you would have some statistics eventually, right?
Well, statistics, I don't know. We are never representative, but yeah, we will see. And we have quite some uptake, so people are already implementing this stuff in their thesauri. So hopefully, yeah, we find somehow a common approach how to make alignment easier.
Thank you. Okay, Gary, back to you.
Well, if there are no more questions from the general presentations, maybe we can turn it back to the panel. It's you have a mentee question, and you also had two from the chat. So which would you like to start with?
Yeah, maybe I could just start with, because we've had a few responses already to the final mentee question. So we originally asked you what your current ontology challenges are, and now it would be great to hear from you whether you think whether any of the approaches that you've been hearing about today could help address some of these challenges. So if you could go back to the mentee link, and I can share that in the chat again, and let us know if any of these approaches resonate or you think they might be helpful. Yeah, that would be great to know. Great, thank you so much. And in the interest of time, if you want to keep responding, that's great. We're going to be collecting all of these inputs. And in the interest of time, I think I'm just going to hand over to Barbara, who wanted to just share a document for anyone to get in touch with us if, in case there are sort of opportunities to collaborate and connect on this work. So I'll hand over to you, Barbara.
So you find it already in both chats in this room here. I think everybody should be able to see this document. That's a minutes document where you could, if you are interested, put your contact there so that you can keep be updated on the work, because Sirko and I and others from the Barrott group will develop services to make this really usable for researchers, not only for knowledge engineers, but researchers on the field. But this is quite some work to do still. And I think what's really great, but we have not yet organized this, is this collaboration with Sukaina and Julia. So we'll see how this goes further. We have no plan, but would like to update you. And I would also be somehow, Gary, if possible, be connected to ASIP, or see also to discuss with the ASIP group if they can help us to identify also bottlenecks and problems with the IADOPT framework.
Excellent.
Yes.
If you send me an email, I would be happy to send it to Dave Jones and Karen Moe. And then Gary also has contacts in ASIP.
Yeah. Thank you.
Surely.
And we would have other questions like, which challenges are still open after this, but might be addressed here as well. So what would you like still to, probably have mentioned them already. Yeah.
Thank
if you are
you.
interested, it's already there. I have already mentioned to put your name if you want.
Okay. This is about time. Ken, you have any last minute comments? Ken Baklowski.
Just that next week we're having the synthesis session.
Yes. We have a
So-
synthesis session on 4th. I would have liked it to be after the last talk on the environmental area, but 11th of May, we have a talk from USC scholar Yolanda Gill. And then on 18th, we start the space disasters track, but and therefore Robert Roberto's talk is postponed to end of May, towards the end. But 4th is where we have a slot to do the synthesis. So Gary, we have no other alternative. I mean, Ken, we have no other alternative unless you can think of something. I'd be happy to share a little bit of sensor and platforms related work that enables Earth observations, which are used for disaster monitoring.
Okay, so we're just inviting everyone to attend next week. And also the week after that when Yolanda will be speaking. So thanks, everyone.
Thank you.
Thank you.
Thank you all.
Thank you all.
Thanks, everyone.
Thank you.
Thank you, Gary.
Bye.
Bye.
Thank you. Great team. Gary, very many thanks for putting together such a great team that gave us a very good set of presentations. Thank
Thank
you
you all.
Bye-bye.
Bye now.
Thank you. Bye.
Thank you.